In our previous session, we discussed the design of using an S7-1200 PLC to control the start and stop of a motor. Today, we will focus on the implementation of this design. Firstly, based on the PLC and I/O hardware wiring diagram, connect your computer to the PLC via an Ethernet interface using a network cable. Supply a 24-volt stabilized power source to the L+ and M terminals of the PLC as the operating power. And connect a 24 volts DC power supply to the 4L+ and 4M terminals to serve as the load power. Then, connect one end of the normally open contact of the thermal relay and one end of a button, and similarly, connect another button's end. Join these ends together, and connect the other ends to the common positive power supply L+. Connect the start button to the I0.0 input terminal. The stop button to the I0.1 input terminal, and the relay contacts to the I0.2 input terminal. Finally, connect the common point 1 end of the PLC input back to the negative power supply end. Completing the input connections. Next, connect the PLC output terminal Q0.0 to the 13th terminal of the DC device KA and the 14th terminal of KNA. To the negative power supply 4N. By controlling the on/off state of relay KA with the PLC, you can control the AC contactor coil through its normally open contact, thus completing the connections. To begin, launch the TIA Portal software and create a new project by clicking Create a New Project. Enter motor start and stop control as the project name and choose a storage location. Such as your desktop. Then click Create to open the project view. Secondly, for the hardware configuration, double-click to add a new device in the project tree and select the controller. You can enter a device name or leave it blank. If left blank, it defaults to PLC1. Select the controller, choose the S7-1200 CPU, and then select the CPU 1215C DC-DC under the CPU. Ensure the version number in parentheses is 4.1. Then OK. Your added PLC will now be displayed. Remember, the PLC's CPU model, order number, and version number must exactly match the actual PLC used. Any discrepancy will prevent the control project from being downloaded to the PLC. After adding the PLC device, a device view window will appear. Select the PLC, then choose its properties, General, and the Ethernet address. Set the Ethernet address to 192.168.0. The first 3 digits must match the IP address in your computer, while the last part can be set arbitrarily. If the first 3 digits do not match your computer's IP address, the project cannot be downloaded to the PLC. To write the program, click on PLC Variables under the project tree and double-click to open the default variable table. In the default variable table edit box, enter the variable names: Start button SB1, Stop button SB2, Overload FR, Output Quell KA, along with their corresponding addresses I0.0, I0.1, I0.2, Q0.0. Click on Program Blocks to open OB1, and the program editing box will appear. Use your mouse to input the contacts: Stop, Overload, Coil, and then insert an open contact where needed. Next, click on Contacts, Open Contacts, and select the variables we just defined: Start button, Stop button, Overload, Output Coil. After completing the program input addresses, the variable names will be displayed below the addresses: I0.0 for the Start button, I0.1 for the Stop button, I0.2 for the Overload FR, and Q0.0 for the Output Quell KA. These correspondences are set up in the variable table, and you can switch between absolute and symbolic addresses to display the program. Once the project, hardware configuration, and program are created, select the Motor Start and Stop Control project. After creating the project, hardware configuration, and writing the program, select the Motor Start and Stop Control project and click on Compile in the toolbar to check if the program is correct. If the program is correct, you can download the project to the PLC. Connect the PLC power supply and network cable. Then select Project Download. Here, you will see the PGPC interface type, which is used to select our interface and network card. Then start searching. Once the search finds the device connecting the computer and PLC, you can download the program, hardware configuration, and program to the PLC. A stop module will appear because the PLC must not be in the operating state to download the program. Click on Load. And after loading is complete, it will ask if you want to start the module, which means to let the PLC start operating. Generally, click Finish. After downloading the program, you can operate the PLC in practice. Operate the corresponding control buttons, and you can observe the motor's working process after the PLC runs the program. This is the electrical control circuit for starting and stopping the motor. This is the circuit for controlling the start and stop of the motor using a PLC. Now, let's look at the operation of the two circuits. Press the Start button, and the motor starts running. Press the Stop button, and the motor stops. Press the Start button again, and the motor starts running. Press the Stop button again, and the motor stops. That concludes today's lesson.